Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the change in the molar Gibbs energy of a perfect gas when its pressure is increased isothermally from 1.0 atm to 100.0 atm at 298 Kelvin. So the first thing you have to note is that we're asked to find the change in molar Gibbs free energy. So that's basically what we're looking for. So that's going to be change in GM. Okay, so that's what we're asked to find of a perfect gas. So we're doing the perfect gas when its pressure is increased isothermally. So isothermally meaning the change in T is zero, or we have just one temperature throughout the entire process, meaning temperature is constant throughout the entire process. So from 1.0 atmosphere, so we've got the P initial to be 1.0 atmosphere, and then the P final to be 100.0 atmosphere at 298 Kelvin. And we're also given the temperature. So that's 298 Kelvin. So we're basically asked to find the change in molar Gibbs energy. So the first thing you have to do when you have this is for you to realize like what formula you're supposed to use after you have written down the information given. And the formula for this type of question is the molar Gibbs energy for the final pressure, okay, equals to the molar Gibbs energy for the initial pressure, okay, plus RT, so gas constant times temperature, ln P final, okay, final pressure divided by P initial, the initial pressure. So that's basically what it is. Now, to be able to like rewrite this formula, so we have the change in molar Gibbs energy, you have the molar Gibbs energy at final pressure minus the molar Gibbs energy at the initial pressure is going to equal RT ln P final, okay, divided by P initial. So you note this. The molar Gibbs energy of the final minus the molar Gibbs energy of the initial is just simply, let me change the color. It's just going to be change in GM, which is what we're solving for, equals RT ln P final divided by P initial. Now we've gotten the equation we're supposed to use. We can just simply substitute. So you have change in GM, okay, equals RT. Since this is a molar Gibbs energy question, equation, and this is a question we're going to be using the gas constant 8.3145 joule per mole Kelvin, because the unit for change in molar Gibbs energy is just going to be joule per mole or kilojoule per mole. So I just wanted you guys to note, because that understanding of the units of what we're solving for is going to determine the gas constant we're supposed to use. So we're going to end up with 8.3145, okay, joule per mole Kelvin, okay, times temperature, which is T, which is 298 Kelvin. So that'll be times 298 Kelvins. ln, okay, P final, we know that to be 100.0 atmospheres, okay, divided by P initial, which is just 1.0 atmospheres. So of course, we cancel out the atmosphere, cancel out atmospheres, cancel out the Kelvin, cancel out the Kelvin. Now, I want to quickly mention something that not everybody might know. It's very, very important for you to note that since we're dividing between two pressure units, we actually don't need to change from atmospheres to pascals or to Newton per meter square, simply because we're going to cancel out the pressure anyway. So whatever conversions we do, maybe if we go from atmosphere to pascal, is really not going to have any effect when you do division. So we can as well leave our units in the original form, which is atmosphere. Because I know usually whenever you're dealing with canceling stuff out in chemistry, normally you're supposed to actually be canceling stuff out, but you have to convert to the units first. But in this case, we're just canceling between two pressure units, so we don't actually have to change the units to the units that would not originally work for this question, since we're just simply canceling out the units anyway. So the value is going to be the same. So the change in molar Gibbs energy is just 8.3145 joule per mole times 298 ln 100 divided by 1 would just simply be 11,410.33 joule per mole. Now, this is like the answer you're supposed to get. But one thing you have to understand is that whenever you're looking at like, whenever you're dealing with like Gibbs energy, it's important for you to know that Gibbs energy as well as enthalpy are usually written in kilojoules per mole. So what we can do is for us to convert this 2 kilojoules per mole. So what we end up with is going to be the change in molar Gibbs energy is going to be 11.41033 kilojoule per mole. And this is basically the answer to our question. But one thing you're also supposed to put in mind whenever you're dealing with a chemistry question is for you to look at how many significant figures, whenever you're dealing with questions that involve multiplication, that is given in the initial question. So we see that we've got two significant figures for 1.08 atmosphere. We've got four significant figures for 100.0 atmosphere. We've got three sig figs for the temperature value. So what you're supposed to use is the lowest number of significant figures, and that's going to be the answer. So we have to make sure we put 11.41033 kilojoule per mole in two significant figures, because two sig figs is the lowest number of significant figures. So the change in molar Gibbs energy actually becomes 11 kilojoule per mole. So this is basically the answer to this question. If you have any questions, please put in the comment section. For those of you who don't know, I'm actually an online tutor for STEM students who are trying to succeed in all their STEM related courses, whether they're in middle school, high school, or college. So if you're a student who is struggling or who is trying to improve your current grade in your class, email me at shahabitutoring@gmail.com. I'm also a mentor for students who are also struggling to navigate their academic career. So make sure you also email me at shahabitutoring@gmail.com. If you have any questions, don't forget to put in the comment section. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.